Hi everyone. This series of videos is going to take you through page 14 in the packet, which is more stuff that reviews series. As an extension of page 13, which also reviewed series, these problems are just giving you more practice of how to identify which of the three major types of series you'll see in each question and how to apply the correct formula. As a reminder, the three major types of series that we saw on page 13 were finite arithmetic, finite geometric, and infinite geometric. So those three same types, finite arithmetic, finite geometric, and infinite geometric, are going to be found on this page as well. I should make the disclaimer right off the bat that question number 7 does not fit any of these three descriptions. Question number 7 is actually a finite quadratic, which we never really studied, nor do I expect you to really be very fluent in. If we were in class in person, I would probably have a few more questions like this that we could explore, but for now, I don't think it's that important. Therefore, you can skip question number 7, unless you really want to try to challenge yourself and self-teach something quadratic, because it's possible to figure it out. And I did include the answer in the answer key for each part of the question if you do want to try to reverse engineer the process and teach yourself how to deal with a quadratic series. It's just not really a pattern that you need to know. It's not a pattern that we'll use in calculus or math analysis, so that's why skipping it is not that big a deal. But again, if you're up for a challenge and want to challenge yourself to do so, you can definitely try to figure out number 7. My goal in this playlist is to just give you a few more examples that you can use to follow through the rest of the questions, beginning with problem 8, all the way down to 11. The little stars that you see next to 8A, 8B, and number 10 indicate which questions I plan on doing in this playlist. Should you need a question answered that's not one of the videos I'm covering, you're certainly welcome to request it via email or during the office hours, and I'll be glad to go over anything else that I might not have necessarily included on YouTube here. The first question I want to make sure I indicate an example for is number 8, letter A, because in number 8, letter A, the phrasing is a little bit new. It wants us to find the sum, so that's not new, sum is just series, of the integers between 5 and 505 inclusive. That's a new word for us. So the first thing I want to make sure that we do in this problem is understand what exactly the integers between 5 and 505 look like so that we can better understand what type of sequence we're dealing with. Is it arithmetic or is it geometric? Then we can understand which series formula we need to use. Finite arithmetic, finite geometric, or infinite geometric. We have to think about these things, but let's know what we're getting into first. The integers between 5 and 505 refer to the numbers, the whole numbers specifically, between those two extremes. Integers are just the whole numbers, or the counting numbers. 1, 2, 3, 4, 5, those are integers. So if I start thinking about the integers between 5 and 505, I'm naturally thinking 6, 7, 8, 9, 10, 11, 12, all the way up to 502, 503, 504, 505. The word inclusive simply means that 5 and 505 are included in the list. So 5, 6, 7, 8, all the way until we get up to 504 and then eventually 505. That would be the list of numbers that we're supposed to find the sum of. Now, of course, that's a ridiculously long set of numbers. So finding the sum by adding 5 plus 6 and then plus 7 and then plus 8 and then plus 9 all the way until you get to the 505th term sounds very tedious, perhaps unnecessary. So this is why knowing which formula applies here could be helpful. If I think about this pattern, 5, 6, 7, 8, this is adding by 1, which means it must be an arithmetic pattern. And since I have a distinct starting point and a distinct ending point, I can determine pretty confidently that this is a finite arithmetic series because there's a defined end point, hence finite, and because the pattern is increasing by 1 each time, hence arithmetic. So I know if this is a finite arithmetic problem that I'm going to use the finite arithmetic series formula that I've been using all chapter long. The finite arithmetic series formula says to take 1/2 times a sub 1 plus a sub n times the difference, a sub n minus a sub 1, divided by the adder plus 1. So I'm going to use that formula. In fact, I'll recopy that formula quickly so that way I don't have to keep flipping back and forth to my notes. Of course, if you want to keep flipping back and forth, or if you have your notes on a separate piece of paper, that's fine. But let's recopy the formula. And now let's see if we can quickly plug in all of this information. I need a sub 1. I have that. That's the first term. I need a sub n. I have that. That's going to be the last term. I have an adder. That's going to be 1. So it looks like I have all the things I need for the formula. I like to check first, though, just in case I need to do any scratch work, just to verify that I have all the numbers I need. So I have 1/2 times a sub 1. First term in that list was 5. The a sub n, last term, is 505, times the same a sub n, 505, oops, minus, sorry about that, a sub 1, the same last term, minus 5, divided by the adder. This series is just adding by 1, so divided by 1 plus 1. Now, of course, you can do these problems with or without a calculator. That's totally your choice. No judgment if you want to use a calculator. At this point, just for expediency, I don't think it's a bad thing to use one. So 1/2, and then you can either do the sum as a sum. You can type 5 plus 505, or you can just do the sum and type that single value. If you're going to be a power user of your calculator, though, just be careful that you're using proper parentheses. If you're not really sure or comfortable using your calculator, perhaps a combination of mental math and calculator could be helpful. For example, 505 minus 5 is 500. 500 divided by 1 is 500. Plus 1 is 501. No, again, you can type all this in if you want to, but mental math might help. Either way, it looks like we're getting a sum of 127,755. It's a gigantic answer, but I'm not surprised, because if you really think about all these numbers that you're adding, 505, 504, 503, 502, 501, 500, those are going to add up really fast. And by the time I add up all of the things in between, a number like this, 127,000, certainly doesn't seem unreasonable. It actually seems like it makes perfect sense, considering the overall magnitude of what I'm adding in each individual part of the problem. So that would be the sum of our series. Now the good news is, since this one's finite arithmetic, there are several other problems on this page that are also finite arithmetic. So you have a choice to make. One option is, after this video, instead of simply watching the next one, you could kind of self-search and find all of the problems on this page that appear to be finite arithmetic and do them in any order that you want to. The other option is to simply do the problems in order. And even if you end up using a different formula, then no big deal. But again, the point of these is to identify the type of formula that you have to deal with and then successfully apply that formula. So make sure that whichever order you choose to do these problems, you're doing both of those separate steps. Identifying the type of formula and practicing using the type of formula.